Let's get a little practice at calculating the elastic buckling load for a member. Things can get a lot more complicated than what we have here, but we'll start off with the very base case. All right, so P sub E is equal to pi squared EI over L squared. Our first example is a round steel pipe, basically a 4-inch pipe. You see the specific geometry here, cross-sectional area, and the moment of inertia has already been provided to us, and the length is 7 feet. Notice this is an axisymmetric system, so when we squeeze it, this is kind of like a straw. We don't know which direction it's going to deform when it buckles, but the basic notion here is that we're going to go in and just put in our appropriate values for each term in our expression. All right, so pi squared EI over L squared. We have steel, so our modulus of elasticity is 29,000 kips per square inch times our second moment of area of relevance at 6.28 inches to the fourth. Right? Notice that in the denominator, then we go from kips per inch squared times inches to the fourth, which means we have a denominator that's kip inch squared, or force length squared. Now I'm going to divide by a length squared, but notice we have inches related in the top. We have a length at 7 feet, so we need to then turn that into inches. Don't forget to square that. That's a common mistake, is to not square that. Yeah, we're sensitive to 1 over the length squared. That's a pretty big deal there. Right? So pi squared times 29,000 times 6.82 divided by 7 times 12, which will be 96, but that, nope, it's not either, it's 84. And then that's squared, that'd be 8 times 12 would be 96. And we get a value that's, wow, enormous, 276 kips, right? We've got inches squared down here, we had kip inch squared up here, so the inch squared divided by the inch squared leaves us with just kips. 276,000 pounds to buckle this 7-foot long pipe, right? That's something to generally take note, that this steel is so stiff and it has a significant effect then on the capacity or the buckling load of the member.